Hello, we are with Chocolate Caramel Confection Corp's Chocolate Caramel Confection Carrier. I'm Jordan Jeffrey, TFA Wright.
I'm Raj Oberoi.
And Thomas Richard Critelli O'Donnell sadly could not be with us. So we're working for a company called Donut Hut, who is getting a larger venture in the chocolate caramel confections area. It's represented by this hat, this beautiful t-shirt here. They are part of the Donut Party. We were trying to target people who would use this chocolate caramel confections to move the confections, possibly if you just have a lot at your house or a big warehouse. It could be scaled to move the chocolate caramel confections quickly and without too much effort. It has to lift 1 kilogram 1 foot in the air. It also moves it sideways a little bit. And we have the design statement here with our large frame without a base plate, a wheel and axle which cranks to wind up the string to pull a pulley which will slide the weight up the inclined plane. And we have, of course, our constraints that it's made of X equipment. It lifts 1 kilogram. There are 3 to 6 mechanisms with a minimum AMA of 3, and it is as light as possible, so we did not include a base plate.
So the weight and the cost?
It was 34,000 pounds today.
Yesterday when we weighed it, it was 3.2 pounds. That was 3.4.
So these were some very poorly made initial sketches when we were just trying to figure it out. This is kind of the idea of the frame with sliding the weight up with a pulley and a wheel and axle.
There's a decision matrix. For some reason the first one was bugged out and it didn't work, so I just started here. But they were all like pretty good designs, but this one won out because it was just really light, pretty easy to make.
So here you can see the pulley system. We have just a gear that's going, or we have a spool area that just winds the string, pulling the pulley up and reducing the distance between the pulley and the tie-off point. Here we have our inclined plane, which is the main thing that you see. It's here, and it just is to slide the weight up. And then the initial input is this wheel and axle. We've got this nice shortened axle so that it can be twisted quickly if you need to wind it up quickly and it's not too large. It's also convenient to have you be able to twist it with 1 finger so it can spin really quickly and it doesn't take much effort at all. And if you get tired in the middle, because there's an inclined plane, there's enough friction to hold it in place as a safety precaution, so you don't have lots of chocolate caramel confections falling, because these chocolate caramel confections are very delicate and fragile, so you don't want them falling down too quickly, or they might get bruised or damaged, and you don't want your candies to be broken because your consumers will not continue to do business with you.
Here's the video of the actual thing in action. He already showed it to you a little bit, but you can see it going up the entire way.
Yeah, we'll move. You get another pole.
What?
Night vision.
So as you can see, it's very easy to wind with just 1 finger. So the AMA of our machine is 109, much higher than the required 3. So because of that, I think this is an optimal candidate if you're planning to scale up this design. I don't know the practicality of this scale of machine. If it is just 1 kilogram, you're probably not going to need a machine to lift it. So presumably this is something that's going to be scaled up to be like maybe like 1,000 kilograms instead of 1,000 grams. And in that case, I think this will be the best candidate because it has such a high AMA. Right now it takes like barely anything to spin the lever. You can hardly even feel that there's any resistance. But once it's scaled up, I think it will be a prime candidate because you will be able to physically push that. Whereas something with an actual AMA, with an AMA of 3, you're not going to be able to move it once it's scaled up to be like a useful size, carrying like 1,000 kilograms.
So the ideal mechanical advantage of the entire machine was 140. The pulley system was 2. It had an IMA of 2, and the incline plane had an IMA of 1.6. But the wheel and the axle does most of the work because it has an IMA of 44.
Which is, we should say, it is slowly, the IMA of the wheel and axle is slowly decreased because that's the IMA in your initial point when the string is here. But as you continue to increase it and wind it up, the string slowly spools and it actually your weight will slowly go faster as the string spools along the axle. Essentially the string becomes a part of the axle, making the axle thicker, and your weight will go up faster.
And then we had an efficiency of 77.85%.
So now we'll do the whole thing, lifting it up once. Alright. So it was sitting flat on the ground. We'll pull it up. Also, despite not having a base plate, it is very stable because the input force doesn't pull it in any direction, so it's very stable. And there it is above the 12 inches, which is actually much lower than this bar.
Thank you for this.